Hello, everyone. Welcome to Developmental Psychology, DEP 2004. I am Dr. Rivera. Now, some traits are passed down through your sex chromosomes, either being passed down through the Y chromosome or they're being passed down through the X chromosome. And I want to focus a little bit on the X chromosomes because the X chromosome has a lot more genes than the Y chromosome. And so there's actually a lot more information that you need in order to be alive. Some children might end up being born with just one X chromosome, and that child is going to have symptoms that are going to be caused by having just one X chromosome. And I'll talk about that in just a minute. But that child can live. Whereas if you only have a Y chromosome, it would be impossible for that zygote to then turn into a fetus. It wouldn't develop. The body would eventually um, get rid of it as if though it was an unviable pregnancy. You need to have that X chromosome. That X chromosome has a lot of information about how to make blood, information about the cones in your eyes, etc., etc. But there is a slight little problem, which is if you have a sex trait that you're trying to follow, you can't use a normal Punnett square because it won't make any sense. So let's talk a little bit about color vision, the cones in your eyes. If you have a recessive trait for color vision, that means that you might end up being colorblind. But there's a problem if you try to do a normal Punnett square, which is here's mom. I'm going to put my capital N, my dominant trait there, and then my lowercase n on the right side. And now I'm going to try to do the same thing to dad. Well, I'm going to take dad and put his dominant trait there at the top. And there's a problem, which is he doesn't actually have a second allele because dads don't have two X chromosomes. Dads have one X chromosome and one Y chromosome. And only the X chromosome carries information about the cones in your eyes. So that means that if you try to do a normal Punnett square, it's going to mess up. So you have to do it a little bit different. And you can kind of see it here, what it looks like, where you're following the X and the Y. So I'm going to show you that here. So I'm going to follow the X and the Y. And so I'm going to start out here with dad. And you'll see that dad's X chromosome is carrying a capital N, a dominant allele. But dad's Y chromosome isn't carrying anything for this trait because the Y chromosome doesn't have information here. Mom is a genetic female and she has two X chromosomes. One of her X chromosomes has a dominant allele, that capital N, whereas the other one has a recessive allele, the lowercase n. Now, from this point going forward, you're going to do it the same way. Just kind of multiply together. So in the first square, I'm going to take dad's X chromosome and mom's first X chromosome. And then in the second square, I'm going to take dad's X chromosome and mom's second X chromosome. In the bottom left square, we're going to have mom's first X chromosome and dad's Y chromosome. You'll notice that the Y chromosome, again, does not have that subscript, meaning it does not have an allele for this trait. And again, in the last square, mom's second X chromosome and dad's Y chromosome. This is going to give us a different kind of information about these individuals' children. First of all, it's going to tell us whether they are genetic males or genetic females. The first child at the top is going to be a genetic female because there are two X chromosomes. Um, and this individual is going to be dominant homozygous. Dominant meaning they have normal color vision because they have those capital N's. And they're homozygous because both the allele that this girl got from mom and the allele she got from dad are dominant. So they're both the same. Now, for this individual is also going to be a female, two X's. But this individual is going to be dominant and heterozygous. Dominant because they clearly have a dominant allele, the capital N. That means they're going to have normal color vision. But they are going to be carrying or carriers of the recessive trait. But they will have normal color vision. Now, the third individual down here is going to be a male. We know they're going to be a genetic male because they have an X chromosome and a Y chromosome. Now, this person is dominant, but they're neither homozygous nor heterozygous because they, in fact, only have one allele. They only have the allele that they got from mom because dad cannot provide that for them. Dad only provided a small Y chromosome. Now, this individual is going to have normal color vision because they have that dominant trait from mom. Now, the final individual over here is also going to be a male. They're going to be a male because they have an X and a Y chromosome. Now, this individual got a recessive trait from mom. And again, it's neither heterozygous nor homozygous because they only have one allele. Dad didn't provide any information here on his Y chromosome for this trait. This individual is going to end up having color blindness. Something is going to be different or wrong with their cones in their eyes, and they will end up developing color blindness. Now, unlike the female, right? If you see over here on the top, this female also has a recessive trait, but this female, the other trait, the dominant trait, protects her from the recessive trait, which would create color blindness. This individual, because they have the dominant trait, they will end up developing normal colored vision. But for the boy doesn't have another allele that is dominant. They only have the one. And so this individual is going to end up with color blindness. In order for a girl, a genetic female, to develop color blindness, she would have to have two X chromosomes, and each X chromosome would end up having to have a recessive trait. That means that dad was colorblind because dad only has one X chromosome. And mom was either colorblind or she was just a carrier. So mom had normal vision, but she was a carrier. And so if they both end up passing, mom and dad both end up passing their recessive trait via the X chromosome, then that girl would end up color blindness. This is why it's much more likely for boys to develop color blindness because boys only need one recessive trait, and then there's never going to be a protection on the other side because dad will never pass down a dominant allele to protect from that. Dad can only pass down a Y chromosome. Also, in this case, boys would develop color blindness always from mom because only mom can pass down an X chromosome to a boy, or to say to a genetic male. Only mom is passing down that X. Dad has to be passing down the Y chromosome. And so um, the your color vision, if you are a male, uh, whether you're colorblind or have normal color vision, that comes from mom. Whereas if you're a female, you're getting an X chromosome from mom and dad. And so your X chromosomes work a lot more like what the autosomes, the other genes in your cells, behave. Now, colorblindness is not the only trait that gets passed down via the X chromosome. Muscular dystrophy, and specifically Duchenne's form of muscular dystrophy, is also going to get passed down via the X chromosome. Hemophilia is also a trait that gets passed down via the X chromosome. One of the things that you get from your X chromosome is the ability of your blood to clot. And so, for example, if you get a cut in your hand, at first it'll bleed, but especially if you put some pressure on it, the blood is going to start to clot. And now you'll stop bleeding. But if you don't have that trait because you received a recessive trait, if you're a boy, a recessive trait from mom, or if you're a girl, you got two recessive traits, one from mom and one from dad, then you will develop hemophilia, which means that your blood doesn't clot. And so, therefore, you can't stop bleeding. And so, even a small cut might end up causing you to bleed to death. Now, there are drugs that you could take today that will help with that. But this is a trait that gets passed down via the X chromosome. Diabetes, or as I say, some forms of diabetes will come via the X chromosome. And as I mentioned already, color blindness comes via the X chromosome. All right, everyone, thanks for watching. Let me know if you have any questions. And remember that the best way to contact me is directly through Canvas. I hope to hear from you soon.